So, we will be discussing on network security, or rather we will be continuing our discussion on network security. For last couple of lectures, we are discussing about network security or the different aspects of the security. So, today we will see some of the things which are more related to TCP IP layer, right. So, as we mentioned that security per se is a phenomena which need to be ensured across the layer, right. Like layers are stacked in at different levels, like starting from top from application layer to the physical layer. However, security comes as a vertical type of things, like it is some sort of a end to end phenomena should be there, otherwise it is making it fully effective will be very difficult, right. So, as also we understand that when we the TCP IP or OSI model came up, and when all the devices or the which are communicating based on these protocols which are defined for different layers, they are not initially made for security purpose, right. They are made to communicate, and whenever we put any security aspects, that becomes more as a hindrance to that things, right. Once you say for physical security also, if you go on checking, the traffic flow decreases, the number of processes increases and type of things. So, that is need of more computational power, need to handle this congestion and type of things will come into play, right. So, there may be some devices which are security enabled, that means they understand that what is the security, some devices which are still not security enabled, right. So, that means if we change the basic protocol stack or the format, then some of the intermediate devices may fail to understand that what is there in the instance. In other sense, it may drop the packet, like say IP packet. IP packet has a specific format or specification based on the guideline or the protocol, standard protocol. Now, for the security purpose, embedding the security, if I change this IP packet, some of the routers may not able to understand that what is there in the IP packet. In other sense, it may drop, it will drop the packet, it will not recognize in the IP packet. So, whatever we do with this protocol stack, whether OSI or TCP IP, we need to keep in mind that a device which is not able to decipher this security information should able to forward this packet, right, as it was doing earlier, right. So, the whole process came up like that. Another thing we will see slowly, another thing is important. See, if we look at the whole protocol stack, so there are different layers, like from application layers. If I look at the TCP IP protocol stack per se, so there is application layer, then transport, then IP, then data link and physical layer, right. So, these have a peer to peer connectivity, right. Transport layer of system 1 when communicating to a system 6 in something, that is a peer to peer connectivity. So, the security at that level should have also a peer to peer way of handling that, or connectivity, or handling those security things, that has to be there, right. So, with this notion, let us look at that what are the different aspects of security means today's networking, and the need of security need not to be explained again, and we do means from our personal day to day experiences or working experiences in office and other platforms, we understand that is a security is a must phenomena which need to be there. So, today mostly we will be concentrating on TCP IP security, has a back to back things for the OSI. So, if we look at our common OSI TCP IP protocol stack, so there are here 7 layers or here 5 layers now. Now, see what we try to say, that one is that should be a end to end phenomena if we want to put security in the things. Another thing, you see, physical layer is basically connectivity, right. In some of the cases physical layer is not in some literature not considered in the protocol stack, it is more of a communication phenomena, right. So, anyway that it is a point to point means hop to hop connectivity, here also data link layer hop to hop connectivity. So, per se the security of this traffic is something under the jurisdiction of some authority, right. Like if there is a physical layer layout in the IIT Kharagpur, so that is a within the administrative control of the IIT Kharagpur authority, and there is a more physical security is most required, that it is not tampered and type of things. Similarly, data link layer is also hop to hop connectivity. So, as such the security of this is also not what we say a wide concern as such, because it is a only hop to hop things type of things, it can be ensured by the two communicating party, right. The challenges come from the network layer, right, because you have a path which is not exactly in your control, it is outside the your network, and you do not know that the path which are the routers and other devices, intermediate devices it is following. So, from that context what we see that from network layer, transport layer, application layer, here the security phenomena are more predominant. So, our discussion will be more concentrating on this, that what are the different phenomena or what are the things reported in different literature and so on and so forth, right. So, if we look at the generic protocol stack, so there should be the these are the different standard layer, that IP, TCP, SMTP is the application layer and type of things, and below that there is a MAC is there and the trailer security protocol and things. So, this MAC is not your this MAC is not basically the MAC what we have seen in the layer 2. So, this is more message authentication code or the code which is required to authenticate this message and type of thing, right. So, in other sense what we say, this becomes encapsulated in a bigger packet which has a header for the security protocol, trailer for the security protocol, but the overall packet when moves along a layer, it should be able to decipher by a router or a device which is not security enabled, right, which is not able to understand this what is this high header security protocol or trailer security protocol, but still it is able to forward this packet, otherwise it will drop the packet, right. So, any layer say it is whether it is IP or transport or application has to follow this philosophy. So, that means the actual packet is somewhere encapsulated along with the wrapped around the security things. So, IP level, the IP security or IPsec is the predominant protocol, is a collection of protocol designed by the IETF to provide security packets to the network level. So, this is IPsec designed to provide security level. In other sense, instead of IP it is IPsec, and the other layers basically able to interpret that things in the similar fashion. So, there are two modes for IPsec, one what is called transport mode, another is the tunnel mode. So, these two mode of communication. So, in case of transport mode, this transport mode is related to the IP layer, not the transport layer per se. So, this becomes a payload to the thing, right, and the actual IP header comes in the front and the IPsec header and trailer are added. So, primarily it protects the payload or in the transport layer payload of the things, right. So, it is transported across the network. So, but the IP header is not protected. In case of a IPsec tunnel mode, here the IPsec header, IP header is updated to a new IP header. So, that is also protected. So, it is sort of a virtual tunnel is made between these two parties and the things goes through the things, right. So, only thing we need to take care, there are some of the fields which are mutable or some of the fields that is source, destination, etc., has to be taken care at the new IP header. We are not going to the details of the protocol, it is left to you to those who are interested can look into the things, but this is the basic philosophy. So, in transport mode, IPsec in the transport mode does not protect the IP header, it only protects the information coming from the transport layer or the payload which is getting from the things, right. Here it is structure is like this. So, it is there at the host B, it is deciphered or extracted in this fashion, whereas in case of tunnel mode protects the original IP header, because it comes with a new IP header and move like that. So, it is a form a tunnel between the two devices or two parties. So, there are different services, access control, message authentication or message integrity, entity authenticity, confidentiality, replay, attack protection, these are supported by this. So, this AH and ESP we have not gone into details of the things, that those are some of the things like authentication header and encapsulated security protocol header, ESP header. So, these are the things, two type of headers what the IPsec will have. We are not going into those formatting, but there are different services which AH can provide and ESP can provide. But if we even keep this part aloof, so we can see these are the IPsec related services which are provided by the IPsec, right. Next come transport layer security or SSL or TLS. So, we are used to this SSL. So, it is the generic version or the IETF supported version or standardized version is the TLS, it is of the SSL basic protocol. So, it acts on the TCP. So, where it basically provides security at the TCP level. So, is designed to provide security at the transport layer. So, it goes on and at the PR transport layer should understand that how to extract the secured information. So, this is the SSL or TLS type of traffic security. So, there are also 4 protocols or sub protocols are there. Handshaking protocol to have some negotiation between the parties. There is a change cipher spec protocol for finding out that which is the what sort of cipher parameters or the things will be there. There is a alert protocol for any type of alert generation things, and finally, the record protocol which basically handles the thing and talk with the what we see integrate with the basic transport layer. So, again we are not going details into those things. So, these are the different type of 4 protocols, 4 sub protocols I should say that at the SSL or TSL level which allows it to handle the scenario, right. So, 4 SSL protocols. So, this provides a security at the transport layer. The other thing is the application layer or PGP protocol. Like PGP is an example scenario, that is say in application layer, these are the applications which are talking to each other, right. So, there is a server application, there is a client application which talks to each other. This can be mail application, this can be something say FTP type of file transfer application, this can be something which is DHCP or type of DNS type of application. So, there can be different sort of applications which can be there. Now, the applications layer has their different type of requirement at their end. Now, in order to handle those requirements, so there are way it handles the security aspects may differ from one to another, right. And the other the major one of the I should not say it may be advantages or convenience for the application layer is the application layer talks to the application layer, it has a more resourceful layer where you can do security decipher at the other end type of things, right. So, at the top it is a layer 7 or layer 5 in the TCP/IP protocol, OSI or TCP/IP protocol. So, that way application layer may be more resourceful thing. So, in this case it is the reference is from the pretty good privacy that is a PGP protocol for mail transfer. So, PGP designed to create authenticate and confidential emails, right. So, pretty good privacy email transfer, the PGP protocol is there. So, this is an example scenario or typical scenario where this security can be security of the application layer can be demonstrated. So, if we look at that PGP protocol per se, so there are email message is authenticated and encrypted. So, it is a something at the email message, it is hashed and a digest is created over that encryption thing is there, that there is a session key which is passed to the which is generated. So, it is Alice and Bob are communicated. So, the communicating. So, Alice private key is embedded or encrypted with a one time session key and passed to the other end, and on the other end Bob decrypt it and work with the key. So, what we see here that I can basically create a message and encrypt it or encapsulate it with appropriate crypto phenomena and then communicate to the other end to decrypt the thing. Now, this is possible at the application layer, because the application layer has a lot of resource on the things, and it can be guaranteed, it can be shown that this to what level of security it provides, that the message cannot be deciphered, right. So, this is at the application layer, and if there are different other type of application layer protocols, they may have some variant of the thing, but the basic philosophy remains the same. Now, with this thing we come to a phenomena like, so we have the standard layers from one end, the standard layers at the intermediate sources. So, I need to put the security at the layer wise, because the whole protocol understands or has a peer to peer connectivity. Now, the intermediate devices, say I have a router which is not IPsec enabled, right. So, either it has to drop the packet if it does not understand what is the header, or it need to handle the packet as as it is going through the things. Now, if the router, it may understand this the packet, but it may not be able to decipher what is inside, because that is the payload is may be encapsulated. But if the header is tampered or header is changed in such a way that the intermediate router does not understand, if it is not IPsec enabled, then it will drop the packet. So, those are things need to be taken care at every layer, that what it is done. So, another thing what we have seen, that from the network layer onwards, the things are more externally or what we say in a distributed fashion, or distributed control things are there, right. So, that is security is more important, whereas in the data link layer or the physical layer, there is more internal controls are there, right. So, these are the two things. With this, we come to another phenomena called firewall, which we are accustomed with. We hear it day in day out, say a network or a organizational network should have firewalls. So, firewall, as the name suggests, it protects the internal network from the external attack, right. It can be both way also, some of them going out of this firewall also can be handled. So, it is something a logical wall between the two networks, right. So, if we look at in a broad sense, so there are outgoing traffic to the global internet, and this is my internal network, and there is a traffic which is coming to the internal network. So, these are the two broader way of looking at it. Now, firewall are effective to protect local systems or meant to protect local systems, protects network based security threats, provide secured and control access to internet, provide restricted and control access to the internet to the local thing, right. So, all type of things try to protect the local systems, protect network based security threats which are network enabled security threats, provide security and control access to the internet, right. So, that is for outgoing traffic. For incoming traffic, provide restricted and control access from the internet to the local local servers or systems, right. So, this is the overall how the firewall are supposed to do, right. Now, the obvious question may come that which layer the firewall works, right, whether it is works in the IP layer, transport layer or some other layers, etc. So, accordingly, if we look at that, there can be different variety or flavors of firewall. One is packet filtered, one is application level gateway or sometimes also referred as a proxy firewall, another is circuit level gateways or circuit level firewalls. We will see one by another. So, in case of a packet filter, what we want to do? We want to filter the IP packet based on my policies. So, firewall say if I say that it filters traffic between this outgoing and internet, on what basis? So, there should be some policy. So, there should be some policy, some implementation of that policies in this firewall by based on which it filters the traffic, right. So, that is the thing we need to have. So, in case of a packet filter firewall, so traffic is filtered based on the specific rules, right, including source and destination IP address, packet type, port type, etc. So, these are things which are filtered based on the these rules. Now, if you see, it is not only IP layer, it also have some thing do with the transport layer. So, nevertheless, but it does not look at the application type of things. So, IP plus transport gives me things. So, unknown traffic is only allowed to a level, particular level in the network stack, etc. So, it is allowed up to this and it is checked, either it is blocked or passed to the outgoing traffic. So, if we see that there are two interfaces of a particular packet filter firewall and this is the maybe the rule. So, any source IP this one, anything is allowed or this anything coming from this are allowed or say blocked. So, which way the things are there, it is allow or block, or anything coming for destination port 23 are blocked, anything coming for source port. So, let us see that this is the allow list. So, anything coming from IP address source, it is allowed, anything coming from for destination 23 is allowed, any request coming from this destination is allowed, or IP port, any source IP is port 80 is allowed. That means, if it is allowed that HTTP traffic. So, it allows HTTP traffic to go out, nothing else. It allows any telnet traffic to goes in and type of things. So, that the thing is that if this is the allow matrix, though it allows the things. The other way, in this form I can basically restrict the how things are going. So, it is something which is called which is also synonymous to this access control list, like so how this access to these internal systems will be done, this is access control list. Now, packet filter router or packet filter firewall applies set of rules for incoming IP traffic and then forward the and discard traffic, filter traffics on both direction. The packet filter typically set up for a list of rules based on the matches with the IP or the TCP header, that means IP address, port number, etc. So, it can discard or allow or forward. So, advantages: simplicity, transparency to user, higher transparent to user, higher speed. Disadvantage: difficult for setting up packet filters rules, right. So, what should be the packet filters rules? A large organization may have huge amount of IP or subnet blocks, and then setting these rules are cumbersome, and lack of authentication, whether the source is authenticated, etc. are not there. The next comes the application level gateway or at the higher level. So, it is also something proxying or the proxy firewall as relay of application level traffic, right. It is service specific, like telnet, FTP, SMTP, HTTP has different type of requirement and things like that. So, it is service specific. So, similarly, traffic is filtered based on specified application rules, such as specified applications such as a browser or a protocol, FTP and combination of those things and type of things. So, that is at the higher level. So, if we see that a typical HTTP firewall, so if it request comes, it goes to that all HTTP packets to this thing. If there is a error, it goes to the return back to the firewall or it is not allowed, otherwise it is accepted packet to the HTTP server to serve the things. So, that is every traffic coming for this HTTP is pushed into the HTTP firewall, like we look at the mail security, every traffic comes to that mail security firewall, which takes a call that whether it is a correct traffic or not, right. So, that is the way it works. So, application level firewall, also proxy server or proxy firewall, relay of application traffic acts as a relay. Advantages: higher security than packet filters, only need to scrutinize a few allowable applications, easy to log and audit all incoming traffic, right. So, disadvantages: additional processing overhead on each connection, gateway as a split point, etc. So, there is a more application, more processing things are required. There is another type of thing, circuit level gateway. So, may not be very popular in the sense we may not be seeing this very everywhere, but there is a thing. This can be a standalone system or specialized system. So, it does not permit an end-to-end TCP connections, right. So, usually TCP connections are end-to-end phenomena. So, this circuit level gateway, it does not permit TCP connection, rather gateway sets up two TCP connections. Once the TCP connection are established, the gateway relays TCP segment from one connection to the other without examining the context. So, that is it breaks the things and create a connection like this, so that it moves like that. So, it is again it acts at a transport layer. Traffic is filtered based on the specific session rules, such as when a session is initiated or by a recognized computer and type of things. So, based on the TCP session. So, as it is a phenomena of the transport layer, it is mostly controlled by the transport layer. So, standalone system set up two TCP connections. Security function consists of determining which connections will be allowed. Typically use situation in which system administrator trusts the internal user. So, this SOX packages is one of such example. Now, regarding firewall configuration, in addition to use simple configuration of a single system, more complex configurations are possible. Three common there are very popular uses. So, one is that screened firewall, like here the traffic comes and it goes to this packet filtering router and goes to the things, right. So, the traffic is connection like this, sorry. So, there is a basin host, which is a more control system, a controlled host, where the services which are only needed are enabled. It goes to that traffic for filtering. There is a information server which says that what sort of security filtering or security feature needs to be energized. So, as we have seen that consists of two systems, one is the packet filtering router and the basin host, and the basin host performs authentication and the proxy function. The greater security than single configuration because of two reasons: implements both packet filter and application filtered filtering. A intruder must generally penetrate two systems to compromise the firewall. So, other one is a screened host firewall, dual home. So, the configuration physically prevents security breach, like here the break is there. So, it goes there and it goes to be there. So, it is a physically it is not logically forwarding the packet, it is physically protect the things, and the packet filtering router is not completely compromised, and traffic between the internet and other host on the private network has to flow through the basin host, cannot avoid that thing. So, that is the way it looks at. And another is the screened subnet firewall, where we have another internal router. So, that means 12 home things are there. So, it is a private and this is the external and this is the internal router. So, that means two layer protection is there. So, screened subnet. So, I can have now three domain, right. One is the external, one is the intermediate, and in the another is the on the private network or the internal network on the things, right. This helps us in keeping several servers like say DMZ zone etc. can be created out here, right, which need not only goes through this outer firewall, also while connecting to the internal thing has to be goes to a internal firewall. So, this is a much better configuration, but as we see that it requires more hardware specification, more configuration issues, and increases the both cost and management of the whole system. And finally, if we try to look at a typical scenario that what today's systems tries to do, one side is that internet connectivity with a IDS, that is your intruder detection systems. Another side is the internal network where things are there. There are two firewall, outer firewall and inner firewall. In between there are several things. One, the things which are should be in the DMZ group like DNS server, mail server, web server, or any other server with the DNS zone. It also has a intrusion detection things which could have compromised this or pass this, but there is a intrusion detection based on the whatever it is receiving the switch. There is a honeypot as we discussed some time back, so that it is where you are expecting the attacks and learn the signatures of the thing. So, this is in the DMZ zone, and then we have this inner firewall for the external connectivity. So, with this let us conclude our discussion on this network security. As I mentioned, the network security per se is not a core part of the course. So, may not be important for your exam point of view, but it is important for our networking concepts or or for practical implementation of network. That is why we thought that we should have couple of lectures on the network security to give you some of the pointers, because this is much deep into the things every subject. Some pointers those who are interested can go into the things. So, as this is the last lecture of our series of courses. So, first of all let me thank you that you have taken up this course. So, what we tried that to look at different aspects of the computer networks and internet protocols at layer wise. We followed a top down approach starting from the application and coming down the things, and tried to see that important factors at a different level. Nevertheless, to say that is there are lot of things which are still need to be explored. What we believe that this will give you a as I was mentioning some pointers to look into different aspects of the things, and all with these days several simulators etc. available, and also some many of you are having some practical implementation at your workplace or college and type of things. So, it will be nice to explore some of the things, but be careful that you should not do something which bring harm to the network, because after all we make this network to have resources shared and able to work together or have that more accessibility to resource. So, with this let us conclude this today's talk, and also let me thank you again for taking up this course. Thank you.